Hello. In the last classes, we were discussing about binary numbers. Binary numbers are very much used in digital electronics. Particularly, they are used to represent voltages. For example, a 1 in the binary number system could be used to represent a high voltage in a digital electronic system. And a 0 could be used to represent a low voltage. These binary numbers are used to establish certain mathematical logic. And this mathematical logic is used to perform certain logical operations in digital electronics. And the basic logic operations, the basic mathematical logic operations are the AND, OR, and NOT operations. For establishing these operations, for establishing these logical operations, we have a set of rules. We have a set of laws and we have a set of theorems. These set of rules, laws, and theorems together form the Boolean algebra. The rules, laws, and theorems are used to perform these mathematical logical operations. And this was first put forward by the English mathematician George Boole. That's why we call it Boolean algebra. So we need to familiarize ourselves with the theorems of Boolean algebra. The first theorem is concerned with OR operation, or logical operation. And the first law is, or the first theorem is, A or 0 equal to A. This means A is a binary number which could be 0 or 1, which is ORed with another 0. This is a plus sign, but we call it OR. This is a symbol of OR operation. So we spell it as A or 0 equal to A. Let A be 1. 1 or 0 will give you 1. If it is 0, 0 or 0 will fetch you the same result, 0. So this is the basic logic behind the first theorem. Then the second theorem is A or 1 will be always 1. If A is, say, 1, then 1 ORed with 1 will give you 1. If A is 0, when it is ORed with 1, you will get a 1. This is how it works. Then the third theorem is A or A will be A. And the fourth theorem concerned with OR operation is A or A complement or A bar equal to 1. A complement is like this. If A is 1, then A complement is 0. If A is 0, then A complement is 1. So a binary number ORed with its complement will give you a 1 always. So these are the 4 theorems associated with OR operation. Then we will move to AND operation theorems. The first theorem is A and 0 equal to 0. This dot is spelled as AND. If A is, say, 1, 1 and 0 will give you 0. If A is 0, then 0 and 0 will also give you 0. So whether the A is 1 or 0 does not matter. You will always get a 0 here. The second theorem is A and 1 equal to A. So the result depends upon A. Let A is 1. So 1 and 1 will give you 1. If A is 0, then 0 and 1 becomes a 0. The third theorem is A and A is A. The fourth theorem is A and A complement is always a 0. So these are the four theorems associated with AND operation. Then the third logic operation, NOT. A NOT operation is A bar bar equal to A, or A double bar or A double complement. A complement is A. If A is 0, then A complement is 1. Then complement of this will automatically become 0. That's why we say A equal to A complement or A double bar. Then we have certain laws, the commutative laws, associative laws and distributive laws in Boolean algebra. Let's start with the commutative laws. A or B. This is the first law. A or B equal to B or A. This means if A is 1, B is 0, it is equivalent to write 0 or 1. 1 or 0 equal to 0 or 1, or 0 or 1 equal to 1 or 0. This is the commutative law over OR operation. Then there is a commutative law over AND operation. A and B equal to B and A. Likewise, we have associative laws in Boolean algebra, and it is like this. Suppose we have A or B or C, could be written as A or B or C. And we have a corresponding associative law in AND operation, and it is like this. A and B and C. This could be written as A and B and C. Then we have distributive laws. A and B or C. So we have AND operation as well as OR operation here. This could be written as A and B or A and C. Likewise, if it is A or B and C, this becomes A and C or B and C. There are two more theorems which are very, very useful and very, very important in Boolean algebra, and these theorems are called De Morgan's theorems. The first theorem is A or B complement equal to A complement and B complement. And the second theorem is A and B complement equal to A complement or B complement. We will come back to De Morgan's theorems later. We need to study that separately. Now we shall do some simple problems using the theorems we have just seen. The first one is A or A and B. Although the dot sign is not here, it is A and B. How could we simplify this? So we know that A is common in the first two terms, in both terms. So we may write it as A and 1 or B. But 1 or B is 1. So we may write it as A and 1. And this is equal to Now the second problem, A and A or B. We can write it as A and A or A and B. This is equal to A or A and B, because A and A is A. And taking A as the common outside, A and 1 or B. 1 or B is 1. So this becomes A. So we write it as A and 1, which is 1, which is A. Now on to the third problem, A or B and A or C. We can expand this as A and A or A and C or B and A or B and C. A and A is A or A and C or B and A or B and C. So we may take A as common from the first two terms. So this becomes A and 1 or C or B and A or B and C. 1 or C is 1. So this becomes A or B and A or B and C. This could be written as A or A and B or B and C, because B and A is A and B. And taking A as common, A and 1 or B or B and C. Now this could be written as 1 or B is 1. So this is A or B and C. This is the answer. Finally, let's do one more example. A or A complement B. This result is very important, and this result is used in many places. This could be written as A and 1 or B or A or B, because 1 or B is 1. 1 or B is 1. That's why we are writing it with A. So A and 1 or B or A or B. A or AB or A bar B. A could be written as A and A or A and B or A bar and B. Or this could be written as A and A or AB, that is A and B, or A and A bar or A bar B. This is big because A bar is 0. A bar is 0. Now, taking A as common from the first term and the third term, A or A bar, or taking B as common from second and fourth term, B, A or A bar. This becomes A or A bar is 1 in both these terms. So this becomes A or B. So the result is A or A bar B is A or B. This is very, very important. Now you have 4 problems given here. You can do these problems on your own.